Hi, so today I'm going to be going over an 820-3115 board that does not turn on. So you get a green light on the charger, but the board itself does not turn on. We're going to troubleshoot this. I'm going to show you what I go through as I troubleshoot it. This is going to be a little bit more difficult than previous videos I've done for one reason. This whole microscope setup is not working the way it's supposed to. So I got rid of my cheapo microscope and got this $1,100 one with the camera and all that so that I could record these videos in real time. A lot of microscopes have that little USB camera, but that wouldn't allow me to record at the same time as the camcorder and narrate in real time. So I got this nice HDMI camera in the microscope. The problem is recently the lens, I could not get it to the point where it matches the focus of the eyepieces. I don't know if the trinocular part of the microscope's not working or the lens is not working or whatever. So the point is I can either see what I'm doing in the camera or I can see what I'm doing in the eyepieces, but I can't do both at the same time. And in order for you to watch what I'm doing, you would have to see, I would have to have this plugged in. So what I've done as a workaround is I'm ignoring the eyepieces altogether, and I have this camera plugged into an HDMI splitter, so it's going to the recording machine and also to my television. The reason this is a pain in the ass is because I'm used to doing this in soldering and actually looking at what I'm doing like this. I'm not used to this. That's just weird to me, and I also get a much smaller field of view through this camera lens than I actually do through the microscope. So I'm going to be working half blind here. And it's, one of the things, I spent about like $1,100 on this. This is not even with the other parts of the recording setup, just on this and this camera. And one of the funny things is that, when you give somebody $1,100 and they already have your money, you find out just how little they care if you actually have a problem with it later once they already have your money. It's the same thing with regular contractors. Like, they will do everything possible to get your money, but once they have your money, it is done. It doesn't matter if the floor is half finished. It doesn't matter if your wall only comes up 3 feet off of the floor. If they have your money, it's done. I asked them if there's any way they could help me with troubleshooting this about a week ago, or if there's anything, do I need to buy anything else? I mean, I even gave them opportunities to upsell me, even in the case that their actual crap that has a lifetime warranty is broken. Microscope got Tom. They don't give a fuck. But anyway, this is what we're doing. So I got this monitor that I'm using over here to look at the schematics and board views, which I'll be recording. I have this TV that shows me what's going on in the microscope camera so that I can make sure that you're seeing what I'm seeing. There are videos where all the work is being done off camera because the visible field of the microscope is different from the visible field of the camera. That's going to be gone for this. And let's get started. So even if this is going to be more of a pain in the ass than usual, I promised repair videos, so here we go. So let's see what happens when I turn this thing on. So first things first, I've told you guys about how there are voltage rails on the machine. There are different voltage rails, and that the schematic will tell you what they are, and that you got to stop guessing and you got to get more scientific with this shit. So I'm going to open up the PDF here because for some reason it decided to die. And okay. Where do we get power rails? Here we go. So you see this over here, where it's giving you a list. Like, here are the rails that are always present. Here are these rails, this rail, this rail. It's literally telling you what all the different rails are. So let's go ahead and start measuring for them. Let's get my charger. I got a clusterfuck of wires here since I have 3 more HDMI cables, or 2 more than I'm used to, just for this stupid convoluted video setup. Ugh. And I could have made this cleaner, but honestly, I really just wanted to set it up so I can fix this shit and get out of here. Just keep in mind, time that I spend setting up video stuff is time that I spend, not going to the gym and doing other stuff that I'd like to do with my life. So the first one that we got here is PP Bus G3 Hot. So as usual, the time that I spend, cleaning this up so that it looks neater for video and getting rid of these wires under my desk, that's time that I spend not living my life. So excuse me if this is not as clean as you would like it to be, because some of these videos have had trolling going, "Your desk is disgusting, blah, blah, blah," and, Yep, keep bitching. I'm sure that will encourage me to make more free tutorial videos. So let's start with the first rail here. So the first one is PP Bus G3 Hot, right? So we're going to take PP Bus G3 Hot, copy it. We're going to go to the board view software. I don't want updates. FU. And we're going to put that over here. Where does PP Bus G3 Hot show up on this board? Here we go. So it shows up on this big fuse over here. So let's go over to the fuse. Oh, I forgot I can't use the eye hole. So there we go. That's the fuse. That lighting is a little too much for the camera. My eyes like light, but the camera doesn't. And let's see what the multimeter has to say here. So I take the red probe of my multimeter and I put it where I want to measure the voltage, and I take the black probe of my multimeter and I put it on grounds, and I get 12.55. And the schematic here says that PP bus G3 hot is supposed to be 12.8. Don't be a jackass. That's close enough. I read all these threads where people are like, this says this voltage is supposed to be 5 volts and I get 5.088. Is that the problem? No. No, it's not. There are tolerances for these things. Realize that it's going to still work even if it's off by this much. You know, everything has a tolerance. So PPVIN S5 HS computing iSense. That's also 12 volts, 12.6. Now, I'm skipping this because I know I don't have to care about it. That's a derivative of PP bus G3 hot. I know that already because I know where it comes from and I've measured this before. So I'm just going to skip that because, again, gym, life, all these other things await me. PP18V5 DC in connector. Let's use some common sense here. Let's use some common sense. The 18.5 volts comes from the charger, right? Now, if PP bus G3 hot, which is created on the board, from the charger is present, do you think my charger rail is working? Yes. I don't have a battery plugged in and I'm getting the main power rail of the computer. So obviously I can skip over that. PP3V42_G3 hot. Okay. I know it's there. I'll explain to you why I know it's there, but I'm still going to measure it just for the hell of it. I know it's there because I have a green light on the charger. If you've watched my video on the one-wire circuit, you'll realize that on this type of motherboard, the one-wire circuit is actually powered by PP3V42. The one-wire circuit is the circuit responsible for getting me a green light on the charger. I have a green light on my charger, which means that PP3V42 must be working because the one-wire circuit is working. So it says that I can measure that on this inductor over here. So let's move over to that inductor. I forgot I can't use the eyepieces. I am really not used to this. Okay, so that's the inductor. It is kind of cool that I can know exactly what you're seeing. I measure it, I get 3.4. So let's go to the next voltage rail, right? PPVRTC_G3 hot, that's 3 volts. I'm not going to explain why I know that that's there, but I know that that's there because that's a derivative of this. Next, PP5VS5. Okay, let's look for that one. N, PP5VS5. It's going to show me everywhere on the board that this shit shows up. So, okay. Now we move over to this area over here where it shows me on the board view. And of course, as you noticed, the board view is always the opposite of how you have the board oriented on the desk. This fucking program, even though it's 20 years old, knows. It knows. It is psychic. It has the ability to jump out of the monitor, to look, to use the webcam that is not even plugged into this fucking monitor, to hack through my computer, go to the HDMI, and see through this camcorder how the board is oriented on the desk. And it always opens the board in the opposite way. If the board is facing this way, it opens it facing this way. If the board is oriented this way, it opens it in the board view oriented that way. I don't know how the hell this software does it, but it always knows. So, and watch what happens when you try to rotate. This is just... But you can't really complain because there's no other resources available. Anyway, back to work. So, over here, C7273, that's where we can measure PP5VS5. If I look into the eyepiece again, feel free to kick me in the balls because that will just mean that I don't know, I don't learn. Okay, let's take a look and measure. Do we have PP5VS5? I have 0 volts where I'm supposed to have PP5VS5. And what does this look like to you? Let's turn the light up and see if you can get the hint without me pointing it out to you. I was this close to going into the damn eyepieces again. This is going to take a while. So see how that looks like crap over there? That is a ped that doesn't exist. And oh, look at this. Blue and green shit. That should look familiar to you. This is what we call water damage. So, we have looked through this, and we have used the schematic in the board view to go through one by one, looking through the power rails. Then we got to one that wasn't present. When I got to the one that wasn't present, I used my eyes and my brain to deduce that this is probably where the problem is. So, let's see what we can do here. I'm going to unplug it, because you have to unplug this before you start working on it, or you're going to blow shit up. And let's start. So I've got my fume extractor turned on here so that I don't die. I'm going to take the RAM out before I start soldering. Here's why you should take the RAM out before you start soldering. Let me explain this. You see how this slot up here is through hole? So this is soldered using through hole soldering. Come on. See that? It goes through the board. That's pretty strong. But on the other side of the board, it's soldered using BGA. Let's see if I can find it. This is so weird looking at this on the screen. And the BGA is crap. This sucks. This is why it's very easy to get one RAM slot killed on a MacBook on these boards. So if you do soldering and you're heating this up with the weight of the RAM in the slot, the weight of the RAM in the slot will actually pull those pads off of the board, and you won't see it. You can never actually see which pad is pulled off, but I assure you it happens because the bottom RAM slot very often dies if you plug it in while the board is still hot or anything like that. And it's just nasty, and it requires that you come up with excuses for the customers to why they don't have a RAM slot, and that's all shit that we're going to try to avoid here. So, first things first, let's remove this chip, because that shit probably doesn't work anymore. I'm also going to remove the fan wire because I don't want to burn it. Okay. Where were we here? Oh, this is going to take some real getting used to, man. You get so little field in this thing. Jesus. Oh, and not to mention how close this thing has to be. This has to be another inch and a half closer ever since this whole setup got fucked up, so... Yeah, there's no... I know I can't expect to do this. I can't even do this. I gotta try to solder like this. This sucks. I should just stop bitching since I know I'm gonna fix this, and I know it's gonna work afterwards, and at least there's money at the end of the pile. So as you can see, I squeeze with my tweezers too hard and actually just scratch the top of the chip, which I'd care about if this chip wasn't trash. But since the chip is trash, I can't really say that I care. Usually I push the chip to see that it's coming off, but when the chip has a pad on it that's burned, usually what this means is that somewhere it's going to be etched to the board, and it's going to give me a hard time coming off anyway. So I'm not really worried here, as I usually am, about ripping pads and traces, because I know that some pads probably are kind of destroyed already. I'm prepared to have to work on fixing that. But usually you know how I feel about how this and how I like to push the chip, tap it, see that it moves, heat it up a little more, and then take it off. So let's see what we have here. So this pad is not actually missing. Most likely the chip itself just got burned out in that area. So let's see what that pad is for, shall we? So that is PP bus S5 HS other iSense. So U7200 pin 16. U7200, come on, find it faster. This is what I got an SSD for. Okay, so pin 16. So that's VIN, PPVIN, S5, V, whatever that crap is. So watch what we're going to do here. Let's see what that's, let's see where else that's mentioned. Yeah, so this is supposed to be 12.8 volts. So that's most likely the 12.8 volts that go... Okay. So that makes sense as to why that is a point of destruction. So liquid got there, and the first point that blew up was the point that had the most voltage. Common sense. So let's see what we can do if that's totally destroyed or if this can be salvaged a little bit. So I'm going to take my Amtech 559 flux. I finally found the smaller needle, by the way. I know I said in one of the other videos, not the syringe tip here, that it allows me to put flux out in smaller quantities, which I'm happy about, because it's a lot easier to work this way. I mean, I could work putting too much flux. I'm fine putting too much flux on and then simply cleaning it off later, because most of these boards I wind up brushing off, and after I brush it off, I put it in the ultrasonic cleaner, just so it looks nice. I don't want customers getting back stuff that's filled with flux and Nasty crap. Okay, my solder is behind this monitor that I'm not used to having here. Here we go. Perfect. I was this close to going the eyepiece again. Alright, so this is where I start soldering without looking into the... I am not used to this, man. This screws with my head. I'm used to this. I don't... This is weird. I think I'd have better luck soldering with my feet in the microscope than doing it like this. This is... What a pain in the ass. Okay. Let's see. So that is barely a pad anymore. That is what I would call a sad shit stain of a pad right here. Okay, put something on the middle pad. Let's just make sure there's continuity here. Okay. Got some nasty flux there. Let's poke through it. Whoa, that is nasty. Okay, let's clean that because that is gross before continuing. Shoo, go away. Okay. I think my multimeter probes actually have some junk at the ends of them. Yeah, that's a hair on the end of my multimeter probe. The hell? Okay. That is gone. So, even though it says a little something left there, that is gone. So I could not measure any continuity on the multimeter. It showed just infinite resistance. So that means that a wire is going to have to get run there. So that little shit stain of a pad that was left wasn't conducting anything. And as soon as I touched it again, the shit just went right away. So what I'm going to do is I'm going to find some jumper wire. The jumper wire that I'm going to use comes from a dead MacBook battery. So I have this little connector here, and I open the wires, and you have this wire that's actually pretty usable for this kind of stuff. The only part that's going to suck is running this wire without having my usual microscope. This is going to drive me up a wall. I've never done this before, so I know some of you guys are going to make fun and go, he can't solder, blah, blah. Yeah, good luck trying to do this shit on a fucking television. A Siki, no less. 30 hertz. I think this is 60 hertz because I'm only running at 1080p. But still, this is a pain. Like I keep going. I think I'm actually better off just doing this than I am looking up here because it's just, it's so confusing. It's not to scale. This is okay, so we're gonna have a wire going over here. Okay. This is just, I feel blind. Alright, so now we're going to take this and bend it. Oh, this is frustrating. Mother... Okay. Dig in there. Now this wire on the other side, the excess. You know when you bend a paperclip too many times it breaks? Same thing here. We just bend it back and forth a few times, and what was once a very strong wire turns into complete shit. I like to use the properties about things that are usually annoying to my benefit whenever I can. Okay, we're going to put a little bit of solder on the end of that wire. I am telling you, this is frustrating. Oh my God. I ordered a new one of those lenses, a different type. I hope it's the lens and not the microscope. I actually got it with overnight shipping, so it should arrive in 2 days. Today's Wednesday. Hopefully it arrives Friday, because this is annoying. Oh my God, did I just do what I think I just did? This is fucking hell on earth. Okay, so that little wire that I created just went away, and I solder blobbed this entire thing. And that's too much flux. And I'm trying to look through my microscope again. Alright, you know what? I'm sorry. You can't see some of this, but no. I need to look through the lens for a second. Okay. Here we go. Back to the drawing board. Another wire. Same thing. Make sure it's in focus so you can see. I know as soon as I get rid of that solder blob that the wire is going to run away. I'm resisting the urge to do this off camera and to just do it in the microscope where it's going to be easy. Although that urge is very tempting. Ugh. I should make this my job interview for new employees. Yeah, I need you to do a basic soldering job for me, but you have to use a television. Maybe it would be easy for them. Who knows? Maybe it's just terrible coordination on my part. I personally find this to be hell. Okay. This is supposed to be a 15-second job. Jesus. Okay. Now it's stayed put. Okay. Get rid of the excess wire. Okay, now time for a new chip. Where do I keep my TPS 51125s? There's a board here that has a TPS 51125 that I haven't stolen yet. Now that is a surprise. I wasn't expecting that at all. Okay. So I use a Hacko A1130 nozzle on my FR801 rework station. I have the heat at 6.5, the airflow at 10. If you use a bigger nozzle, it heats too much of everything around it. If you use a tiny nozzle, you burn the chip on one area so it doesn't work again, but without removing it from the board. So the 4.4 millimeter Hacko A1130 nozzle is what I like to use for this. I was just about to look in the microscope again. I'm losing it. All right, anyway. This is... You can't even see the whole chip in this view. I'm tempted to do this outside of the microscope, but I said I wouldn't. All right, I'm going to at least align the thing in the microscope. I mean, at the very least, put the... so I can see the whole damn chip. At least somewhat proper. Okay. Now we go back. Yeah, I was looking at the whole chip. Right now you're looking at 1/8 of it in this camera. So that's that. Okay, that is a complete clusterfuck, which is exactly what I expected. There's a reason I got that lens with next day shipping, because I ain't going to be doing it like this for long. This is hell. Alrighty. Get this up here. I don't like complaining constantly, but I honestly didn't think this would be this much of a bitch. I really thought this would be easier. If I knew it was going to be this much hell, I would have totally not put the camera up for this. Let's see if that thing's even attached now. Okay, is my wire attached? And the answer is no. Of course it's not. You couldn't see it while you were putting the chip down. Okay. Okay. Let's get my thinner solder. Here we go. Okay. Just to make sure it is making proper contact, I'm gonna heat and push it down a little bit. This reminds me of the soldering video I did where I actually had the camera on a tripod and I was using the camera's viewfinder for my work. That was a long time ago. Alright, so I'm getting 7 volts on PP5VS3, so what I decided to do there for a second was I just wanted to redo what I did, except with the ability to actually see what I was looking at. So that's what you was off camera. Nothing overly exciting, and I get something. I don't get 0 anymore, but I don't get what I want. So what I'm guessing is that the dead board that I took that chip off of had a dead chip. Wouldn't that be a surprise? Wouldn't that be something? Can you believe that the board that I decided to steal something from that was dead had a dead TPS 51125 on it? I can't imagine. I'm looking through my collection of boards to take this from, and I don't like them very much. I don't like these at all. They're all disgusting. Yuck. Well, let's see. What are you gonna do? Can't cry over dead chips. I can't cry over my wire running away, though. That's just tragic. Sorry, people, gotta do that in the microscope. Can't drive myself nuts anymore. You get the point, so hopefully you'll forgive me if I decide to make my life a little easier by giving myself the treat of seeing what I'm doing. I'm going to solder the chip on in the microscope because I don't feel like it taking forever again. I'm sorry that you don't get to see it, but my sanity is important here. Okay, now that that part is done, so I soldered on a new one. Sorry for doing it off camera. I just started losing patience for this. We have a new problem. So the new TPS is soldered in place, but this doesn't look very good. This is where I think my problem is going to be. So somewhere over here. Let's just see how much of that has continuity, and let's see if those probe points are totally destroyed or savable. Let's see. Let's get this in the beeping mode. Also, let's just clean a little bit. I'm hearing beeping in my head. You're not supposed to hear beeping in your head. This is a frustrating experience. When you were a kid and your parents used to always say for anything that was annoying or irritating that it builds character? I'm here as an adult to tell you that that's not true. Annoying shit is just annoying shit. Character is great. Getting to the gym before it closes, that's really what I'm about. That's better. Finally. Okay. So even though that resistor measured properly, what happened is, and I wish you could have seen it under the camera, but you couldn't, because I just decided to do it on my own since this shit was driving me nuts, is that the pad under it actually had there was a pad, so this resistor, let me really point out this little piece of shit here, that thing. So on one end, there was a pad, and there was rust, and then there was the pad. So there was actually a layer of crap under there that you couldn't see. So when you looked at it, it looked like that resistor was soldered to a pad, but that resistor had literally just a bunch of rust under it. So in addition to the chip being bad, it was also that feedback resistor. So let me show you what that thing does. So I have a fan spinning right now. Here, if you don't believe that is spinning, here, let me turn it off. See that? That's a fan that's not spinning. Dusty fan. It looks nasty under the microscope. Now it's a fan that is spinning. Let's point this crap out. R7260. So R7260 is right over here. So here's how this thing works. So Q7260 and Q7261, this is what's called a buck converter. So what this does is it takes the 12-volt rail and it turns it into a bunch of pulses of 12 volts. Those pulses of 12 volts, by using this inductor and these capacitors here, wind up getting smoothed into an even 5 volts. So you have 5 volts, you have 12 volts, then 0, 12 and 0, 12 and 0, 12 and 0, and when you average it out, you wind up getting 5. So right over here, where the pulses are occurring, there is a resistor in line with a capacitor. So you have R7260, then C7260. And it's giving some information back to the U7200. And if it doesn't get that information, it's not actually going to create 5 volts. So when all that's said and done, it works. So let's go over what we did here today. The first thing that I did is something I'm never going to do again, which is decide that I'm going to do a video without having a proper microscope. I like you guys. I want to do videos regularly for all of you. I like you. I want to do videos regularly for all of you, but no. This is a one-time thing, and I am never torturing myself by trying to solder into a television with 25% of my viewable space again. We went through the power rail, so PP-Bus G3 Hot was there, PP3V42 was there, and then we went to PP5ES5, and when we were supposed to have 5 volts, we noticed that we had 0. After that was done, we looked in the area of PP5ES5, and we saw, let's sew it on here, and we saw that there was some traces of liquid damage. So what we did is why does lint keep getting on the end of this? So what happened is we took a wire and we ran it from here to where the pad was missing under the chip, and we also replaced the chip responsible for PP5ES5 and PP5ES3. Then, after that was done and completed, after lots of cursing and misery, courtesy of the microscope setup, I noticed that it still wasn't working. So we're getting 5 volts, 0, 520, 520, it wasn't working. I took a closer look over here and I realized that in this section, that still kind of looks fucked up. It's just, it'll move itself into place once. After that, I realized it still wasn't working. The voltage was going from 5 volts to 2 to 0, 5 to 2 to 0, 5 to 0. And that was happening because the resistors that I just showed you look very messed up, and there was actually rust sitting under the resistor where it was supposed to be. So I decided to replace what was in the circuit over here, which is a capacitor going to a resistor, and that is this. So we have this and this were replaced. And now we have the fan spinning and it turns on, and as I like to joke on this channel, because many of you who send the stuff to other places are aware of, if we see the fan spinning, we think it's done. So this is going to wind up getting ASD'd and Apple service tested and all that good stuff to make sure that it actually works. But for the time being, since my voltages were not present and I fixed my fault, I'm pretty much done with this video. Now before I get to fault testing, this board is going to be going into... This board is going to get acid brushed, alcoholed, ultrasonically cleaned, because I don't like using that much flux and leaving a mess. I want this to leave where you can't see that I did something. So after this is done, I'm actually going to cover it in a conformal coat pen. So after it goes to the ultrasonic and after it gets acid brushed and cleaned, I use this stuff called Circuit Works Overcoat Pen. They make it in different colors. You can get it in green, black, clear, and you put it over there. It covers the wire and insulates it from anything falling on it. You know, let's say you drop a little piece of metal in the board. You don't want a trace to be able to short to ground, and that wire is a trace at this point. And I want it to look like I wasn't there, ideally. Again, you got a lot of customers that go on and on going, are you voiding my Apple warranty? What are you doing to my Apple warranty? Honestly, I'm sodomizing and destroying your Apple warranty, but I do my best that you really have to look for a while to figure out what I did. I may make messy wires for quick troubleshooting. I may make messy wires just to get an idea of what's going on. As I've stated in previous videos, I don't like going nuts with neatness before I know what the problem is. I give myself a certain amount of time to spend on each board. I want that time to be spent troubleshooting the problem. I don't want that time spent on arts and crafts. Once I know what's actually wrong, once I know I fixed it, by all means then I can put it into the pile of arts and crafts for cleaning, for making the wires look nice. But in the beginning, I just want to see that I solve the problem, because you don't want to waste time on rabbit holes. You don't want to waste time on a rabbit hole board, which is a board where you're just following a little rabbit to hell. Eli, the computer guy, has a great video on this, on the rabbit hole to hell, that all of you should watch. It's applicable to almost any business, and I should actually link to it here so that you can see it. And that's about it for today. So hopefully you learned something. Hopefully it wasn't frustrating watching me attempt to solder using a television. If you have any questions that are not dumb, post them in the comments, and I will do my best to get back to them as time permits. And have a good day.